So this one doesn't give us any graphs or anything, but it does give us a lot of information in these first couple sentences, and then the individual parts give us some information for different pieces within them. So it says that f is continuous, or has a continuous second derivative for all x, so that tells me that it's smooth and continuous, and that f is smooth and continuous. And actually f prime is smooth and continuous, since it says that f, the second derivative, is continuous. Anyway, they give me f of 0, f prime of 0, and f double prime of 0. And then they define a new function g. Actually, they define g prime, and they base it on some information about f. So we'll start with A. They ask for the tangent line to f at x equal to 0. So whenever I hear tangent line, I think y minus y1 equals m times x minus x1, point slope. So my x1 is going to be this 0, so I'm going to have minus 0. I can put x minus. My m, well, we're looking at tangent line to f, so m is going to be equal to f prime, and since we're doing it x equal to 0, prime of 0, and look, that's right here, so m is equal to negative 3. So I'm going to have equals minus 3 times x minus 0. And then my y value, my y1 is, well, once again, we're looking at tangent line to f. So that's just going to be f of 0, which, once again, is right there, so it's 2. So I get y minus 2 equals that thing. And I would just leave it like that, point slope form. If you wanted to, you could multiply and move things over, but I think you're more likely to make a mistake. Minus 3x plus 2. So part B asks us if there's sufficient information to determine whether or not the graph of f has a point of inflection at x equal to 0. So first thing, I want to think, all right, a POI, point of inflection, is a change in concavity. So I'm kind of writing out my thought process, which you would have to include some of this in your answer. But a POI is a change in concavity. So usually for points of inflection, I look at the second derivative. And notice we're looking at x equal to 0. So I have f of 0, I have f prime of 0, and look, I have f double prime of 0. So that's good. I know f double prime of 0 is equal to 0. Now here's the problem. I don't know what f double prime looks like close to 0. In order to get a change in concavity, I need f double prime to change from positive to negative, or I need f double prime to change from negative to positive. So if you think about it, if I were to I know that it could, right? I don't know that I can't rule out the possibility of a point of inflection. But if this was so I kind of have 3 separate cases for f double prime. I could have f double prime. They're all gonna, or sorry, 4 separate cases. So I could have f double prime go like this. Doesn't matter if it's curvy or not. I could have f double prime go like this. And that would fit this, right? And in these 2 cases, I would have a change in concavity because the second derivative clearly changes from positive to negative or negative to positive. The 2 cases that aren't quite as obvious are, I could have it look like this, f double prime. These are all f double prime. I could have f double prime look like that, where yes, the value of f double prime is 0 there, but it doesn't change from positive to negative. It goes negative, 0, negative. Or I could have f double prime look like that. And once again, notice it doesn't, well, it shouldn't go below the axis there. So in these 2 cases, I would have a change, or I would have a point of inflection based on this information. But in these two cases, I could have this same thing be true, but not have a point of inflection. So because I can't exclude those cases based on the information that they've given me, and notice this fits the whole continuous second derivative. Because I can't exclude these two cases, my answer is no, not enough info. And you would have to explain some of this stuff, and I think on the PDF I've probably done a close to minimum amount of explanation. You could go less than what I have in the PDF because I wanted that to help you. Anyway, that's all for this one. Well, there'll be another video for C&D.